Right. Before we start, a couple of things that I just want to highlight. Um, I sent a quiz for you guys to do. Did you see it? I know Joshua, you attempted it. Others, did you see it? I sent it on Google Classroom as well as on your emails, I think.
I'm not finished with it.
Huh?
I'm not finished. I'm still busy.
Or the one that you answer on the computer and submit. You saw it.
No, I didn't see it. I'll look at it now after class.
Yeah, you must check on your what is this? You must check
Google Classroom.
Google
Google
Classroom
Classroom.
as well as your email. Joshua, you got it in the email. Ne?
No, Google Classroom.
Google
The
Classroom.
first one was email. Second one was Google Classroom.
Yeah, the Google Classroom, I tried to post it today because I saw many people are not responding. So I'm not sure why.
Okay, so
Yeah.
I'll take a look at my email.
Yeah, please just answer that one as well because it's at least it gives you picture as to how far people are. Right, then we are done with
So, when are we going back to school?
yeah.
When are we going back to school? Because they called our parents.
Did they call or they send a WhatsApp message?
They called my mom
When?
What did it say?
last week. They said that 30% of the parents are allowing their kids to come back to school. So they're still waiting for like the department to say if we can come to school.
Yeah, I think many learners they it looks like they want to go back to school. So I think since us it's a smaller school, so I think the department is allowing us to go back, despite the grades to say grade 11, grade 12 and 7. But for us, I think they're allowing the grade 11, 10s. I think almost everyone to go back provided we have got, I think, sitting arrangements and everything in place.
Yes, sir.
Yeah, so I think they've sent it, they've sent the request to the department, they're waiting. Once that response comes, then I think they will notify you as to when you're going to go back to school.
Okay, sir.
Yeah. Okay, then we are done with the topics here. We're going to move on to term three's work. So that's why I need to find out as to how far are you guys in terms of the work that we've been doing. Ne? Right, so I want to find out as to whether you are at par or you're still behind. If you are behind, please try and catch up because now we're starting on term three's work. And there's some information that I got from the facilitator. They say your final exam, the November exam, you're gonna write only one paper, but it's a combination of paper 1 and paper 2, and it's gonna be out of I think 150. Yeah, can you hear me?
Yes, sir.
Yeah,
Yes, sir.
yeah, and there are other topics. There are other topics that I think have been taken out. All right, there are some topics that have been taken out, so I will let you know. I'll show you. I think maybe in our next lesson um, on Wednesday. I'll show you as to some of, but it's not much for you grade 10s. Just the other part for ionic compounds, molecular compounds like that. That's the topic that is out. But the rest they are there. And the last one to do with I think the hydrosphere is the topic that is normally done in term 4. That's the one that is been taken out. So basically everything else is still there. But still, remember, it creates a base for you So it's important to know some of these topics here, right? But I'll show you on Wednesday as to which topics they've done away with because of the time. All right.
So,
Okay.
can I ask,
Yes.
like, since like now they're cutting down on the topics, won't it like have an impact like for like our further studies, or is it okay for them to cut down some of the topics?
Because I think basically what they're checking is to check the topics that are there, but they don't have a link to your grade 12 or grade 11 exam somewhere somehow. That's what they're looking at. If that topic maybe you are not, it's not examined like in grade 12, then they take it out. Or if they see maybe it will be covered again in grade 11, then they take it out because they know there will be a chance to revisit that particular matter in grade 11 and so on and so on. But the ones that are not that important, that are just there for knowledge sake, but they are not examinable at grade 12. Some of them they are taking out, but they're not taking out a lot. Just for grade 10 is not much. The topics that have been taken out, which we bit worried, is the one in grade 11 because grade 11 they took out geometric optics, which is quite important. But remember what they said. They said the work will have to be covered in the following year. So rather, maybe the topics that they've taken out, if at all they've got importance, then we will do them because we don't want next year to be coming back again and doing grade 10's work. But for us, it's not much. It's just that particular topic, but we have done it anyway. But you must just know that part, it's not going to be part of your exam. Right. Okay. Then we continue. So we're looking at term three's work. I've posted a consolidation activity today, just to summarize electricity. I think you have seen it. So please do that one. I've put a due date for Wednesday at 6. So please try and do that so that we have time to revise it. Maybe we'll revise it on Friday. Then there's also a quiz that I've put in. Please do that quiz. It's just a drop down where you choose the answers, then you submit, then I'll mark it. Some of the answers that were there were wrong, but as you submit, I will correct it. I'll correct my the answers to that. Don't worry about if it's giving you 0 or if the answers are wrong. It's fine. I will mark it. So don't worry about that one. Right. So we move on to term 3. So the topic that we are looking at is chemical change. So it's chemistry. We're doing physics, which was electricity, electrostatics, and magnetism. Now we are looking at chemical change. All right. So chemical change, basically, we're talking about electrolytes and the extent of ionization is measured by conductivity. All right, then we've got describe a simple circuit to measure the conductivity of solutions, relate conductivity to concentration of ions in solution, solubility of particular substances, type of substance, some of which are sugar, some substance such as sugar dissolve but does not affect conductivity. So this is what we're looking at today. Right, so let's move on. So the first part, the topic there, the subsection is reactions in aqueous solutions. All right. So basically, you started to do this in grade 7 to 9, where you looked at chemical equations to represent reactions. You looked at the balance equations. You looked at some acids and bases in those lower grades. So in grade 10, we are now looking at ions in aqueous solution, their interactions and effects. We look at electrolytes and the extent of ionization as measured by conductivity. We're going to look at precipitation reactions. We're going to look at some redox reactions and so on and so on. Other chemical reactions types in water solution. So we'll look at different types of reactions. Then in grade 11 and 12, you look at reaction rates, you look at chemical equilibrium, you look at acids and bases, you look at redox reactions, you look at solutions, So this one is just creating a foundation for you guys. Okay, we'll move on to definitions, some of the definitions that you need to know. Okay, so we have your glossary there of terms. You've got aqueous. What is aqueous? It's occurring in water. We've got dipole. This refers to a molecule which is one end that is partially charged with respect to the opposite end. So there will be two poles, one negative, one positive. Then we've got hydration. It is the process by which ions from an ionic compound become surrounded by water molecules in aqueous solution. Then next one is dissolving. All right, we've got dissolving there. Dissolving, the process by which solid ionic crystals break into ions in water. Electronegativity. This is a measure of the ability of an atom to attract a shared pair of electrons in a chemical bond. There's something is missing. A is missing here. So it's supposed to be shared. I'll correct that one. Right, dissociation, what happens when ions in a crystal lattice are separated from each other and go into solution. So they were together, then now they dissociate, they separate. Concentration, the number of moles of solid per unit volume. We're gonna do the calculation of concentration and you'll be given the formula for this. Then a mole, we spoke about a mole. This is a quantity of matter that contains a certain fixed number of particles. Normally we use 12 grams, the amount of particles in 12 grams of carbon 12. I think that was the explanation that we gave earlier on. Electrolyte, a solution that conducts electricity because it contains ions or it has got free ions. A precipitate, insoluble solid that forms as a result of reaction between two substances. Some of these we'll talk about when we get to those particular sections. But the top ones are the ones that are important for now. Okay, then we start. Ions in aqueous solution, all right, their interaction and effects. So introduction, for substance to dissolve in water, the particles have to interact with water or any other solvent. So water is the common solvent that we have, but the other solvent again, where you can dissolve a solid, but water is the common solvent. The results of this process are important as they help us to work out what is actually in the solution. Right? Explaining the mechanism of the solution. The explanation of how solution in water occurs lies in the polarity of water. So water is polar. All right? Water is polar. What do we mean by polar? We know there is oxygen and hydrogen. And oxygen is more electronegative than hydrogen. So oxygen tends to pull electrons towards itself. When it pulls electrons towards itself, then we're going to have two regions where one is partially negative and the other one is partially positive. So reading the next point there, it says the oxygen-hydrogen covalent bond in water is very polar because of the large difference in electronegativity between hydrogen and oxygen. So what is the electronegativity for hydrogen? 2,1, and for oxygen 3,5. So oxygen is more polar than hydrogen. This means that the shared electrons in each bond spend more time over the oxygen end of the molecule than they do over the hydrogen ends of the molecules. Right. The molecule is an angular shape, and together with the polar bonds gives rise to a molecule in which one end is partially positive or partially positively charged and the other one is partially negatively charged. So the one that is negative here, that's your oxygen, and these are the two hydrogens here. All right, we are using a space filling model to illustrate this. Right. Okay, so we go to the next one, representation of water molecule, showing that that's what we have as a water molecule. Then the symbol that we have there, all right, that's partially positive. It indicates partial charge. That's a Greek letter, right? The diagram shows that the hydrogen ends of water molecule are partially positive and the oxygen end is partially negative. A molecule that has these properties is called a dipole. So it has two poles. Di means two. Pole means two regions of opposite charge. So it has two regions of opposite charge. One partially positive, the other one partially negative. When an ionic compound is placed in water, the positive ends of the water molecules are attracted to the negative ions, and the negative end is attracted to the positive ions. Right. So basically, what are we saying here? We are saying if you take sodium chloride, sodium is positive and chloride ions are negative. If you put them in water, water is going to approach it. If it goes to sodium, which is plus, water is going to approach it with the negative end, which is the oxygen here. Right, my system is a bit slow. I could have shown you writing on my smart note here, but my system is a bit slow. I'm worried it's going to take time, but I'll try to show you that. All right, so there are many water molecules that are attracted to each ion, and the electrostatic force of attraction that comes about between the molecules and the ions are strong enough to break the ionic bonds between the ions and thus remove ions from the lattice. So basically, this is what they are illustrating here. But let me try and open my smart note and see if I can illustrate what I'm trying to say here. Okay. My system is a bit slow. Let me try and open it. All right, let me open a new page here. Not responding. Okay. Okay, let me try. It's slow. Okay, so here basically what I'm trying to say is this. You've got water bonded to you've got oxygen bonded to hydrogen. Bonded to hydrogen. Right, then because oxygen is more electronegative, what is going to happen here? This side here is going to be partially negative, and this end here is going to be partially positive. This side here is going to be partially positive. It's freezing here. Okay, it's going to be partially positive. So if you take, for example, you take sodium chloride. You take sodium chloride. Right, sodium chloride, we know sodium is a metal, so it's going to be negative. Sodium is going to be positive, and chloride ions are going to be negative. So that's a plus, that's a minus. Right, so when water approaches the sodium chloride, the oxygen will be in front. So there will be oxygen in front, and the hydrogens will be at the back. So the water is going to surround the sodium ions in this fashion here, where the oxygen is in front. Right, so all of these particles are going to surround the sodium ion, and that's how it splits the two. So sodium will go one side, and the chloride ions will go one side. And the chloride ions, when water approaches it, what is going to happen? You're going to have your Cl minus. Right, then water, when it approaches, your hydrogen is going to be in front. So you're going to have your hydrogen in front. You're going to have your hydrogen in front here and oxygen at the back. When water approaches it, it's going to be like that. Then you've got your oxygen at the back. Why? Because like charges repel and unlike charges attract. So when the water that is going to approach the chloride ions is going to be like this, right? It's going to be hydrogen in front. Why? Because hydrogen is partially positive and the chloride ion is partially negative. And when sodium is approached by water, what is going to happen? Oxygen is going to be in front, hydrogen at the back. Why? Because hydrogen is partially positive and sodium is partially positive. Like charges, they repel. So in such a way, when water approaches that, then we call it hydration, because these two ions are going to be surrounded by water. Then they are separated. Then in solution, that's how the water, there will be a thin film of water around the ions, right? Which is not gonna make it possible for the two to come back and attract again, because these two are unlike charges which will attract. But that film of water around it, because of hydration, it will split the two. So now we have got positive and negative ions in solution. And that solution is gonna, it will be able to conduct electricity. Right, I go back to the main handout that I was showing you. Right, so this is what is going to happen here. So we're going to have your positive ion, like your sodium ion. Then it's surrounded by water, but the one that is in front is your oxygen, as you can see there. That would be your oxygen. Then the one that is at the back, that is your hydrogens. That is for a positive. Then for a negative, the hydrogens are going to be in front. Then your oxygen will be at the back, because like charges repel and unlike charges attract. So that's the dissolution process, right? So the ion, if it is salt, then the salt is going to dissolve. That's how it dissolves, by separating the positives and the negative, or by separating the cations and the anions. Right, we move on to the next one. The ions from the solid are surrounded by water molecules, and the layer that they form around the ions prevent the ions from returning into the solid phase. This process is called hydration, right? So you must know those definitions there. Then the next one, the process that occurs when ions separate from other ions in the lattice and go into solution is called dissolving, right? So because of water is coming to split the two, then the substance, we say the substance is dissolved, because the ions are separated from other ions in the lattice, right? Then moving on, representing the dissolution process using balanced equation. We can represent this using a balanced equation. How do we do that? Right, we're going to show you now. Right, it says the dissolving process can be represented by a reaction equation. Ensure that you learners, you understand that this is a physical process, right? It's not a chemical process. It's a physical process. No new substances are being formed. It's just the splitting of the two, right? Although ionic bonds are broken during solution, no new bonds are formed. So remember, we looked at physical change and chemical change. So this one is a physical change, because no new substances are formed. The ions are said to have dissociated. Some of the example equations are shown below. So you've got your potassium chloride, right? It disintegrates in the presence of water to give you K plus, which is aqueous, plus Cl minus aqueous. Right, so here it's taking us back to crisscross, the one that we did first term. So you need to know the charges on these anions and cations. Simply because potassium and chloride and chlorine, they are in the ratio 1:1. Therefore, it means the charge is there. It's also 1 plus and 1 negative. So that's how you get that. All right, then you make sure you balance your equation. If we check for KCl here, we've got 1K on the left-hand side, and here we've got 1K on the right-hand side. Cl, we've got 1, and here we've got 1, so the equation is balanced. So that will be the dissolution for potassium chloride if you put it in water, right? That's how it dissolves. Then we move on to the next one, sodium sulfate. Sodium sulfate, we've got Na2SO4, all right, in the presence of water. So you're starting with a solid, that's your solute. You put it in water, it's going to dissolve. When it dissolves, what are the ions that are going to form, right? Sodium, you check here the ratio here. The ratio is 2:1. So therefore, it means sodium must have a charge of 1 and the SO4 must have a charge of 2. And we know metals are always positive. So sodium is going to be a plus. That's where we get Na plus. And the SO4 is the anion, right? It's a polyatomic anion, right? So we're going to have SO4 2 minus, aqueous, all right? Then you balance. When you balance, you check your sodium. This side, you've got 2 sodium ion, sodium NAs. So this side you have 1, so you have to put a 2 here to balance the sodium. SO4 is just 1, and this side is also SO4. That's how you balance that. So this is how you represent the dissolution process for sodium sulfate. Make sure you balance and make sure you include the symbols. So you're going to have your sodium, your solid, sodium sulfate. It's a solid because you're taking a solid like salt, right? It's a solid. Then you put it in water. That's why there's water on top here. That's your solvent. So your sodium sulfate is your solute. You put it in the solvent, it's going to dissolve to form these respective ions in that solution. Then we move on to the next one. Aluminium fluoride. So you've got aluminium Al and F3. The ratio is 1:3. So it means aluminium is 3 plus and the F is minus. Then you're going to get your ions. After they've dissolved, you're going to get Al3 plus, aqueous, plus fluoride ions, F minus. Then you balance. The fluoride ions here, they are 3. So you put a 3 here to balance the fluoride ions. And your states, you're going to have your solid, because we took a solid, then we put it in water. Aqueous. That aqueous also could mean the aluminum ion is surrounded by water, right? That's the aqueous part. There's a thin film of water surrounding the Al3 plus, and the fluoride ion, there's a film of water surrounding it. That's why we put the word aqueous. Right, we move on to the next one. Just explanation. The 2 in Na2 refers to the fact that there are 2 Na plus ions in the crystal lattice. It does not mean a molecule of Na, right? That is why we write the last 2 separate ions in the equation. So just to explain that 2 that you have on sodium. Remind of the need to put phase symbols in the equations. So learners, you need to remember, you must add the state symbols or the phase symbols, your aqueous, your solid, and so on and so on. Note that all ionic compounds are solid, so their formula should also, you must always have an S. So they must be followed by an S for solid. Water may be placed over the arrow, but it's not necessary to do so. However, water must not form part of the balance equation. You just put your H2O on top to just show that water is your solvent, but it's not necessary to do that. Then there's a worked example here. There's an example that we have here, calcium nitrate. All right. We've got 10 minutes left. Let me see if I can do this one quickly. I don't know if my system has improved now. Let me try this. Calcium nitrate. The system is slow, so I won't be able to do this one. Okay, fine. Let's look at this. You have got calcium nitrate. When you write the balanced equation, what are you going to get as your product on the right-hand side? What are you going to get?
Ca.
Ca, and what is the charge?
2 plus.
2 plus. How do you see that it is a 2 plus?
Reverse. It's just because NO3 has a subscript of 3. And then you have then reverse crossing gives Ca2.
Right, so the ratio here is Ca is 1 and the NO3s, they are 2. So the ratio is 1:2. Right, so the one that is that is more, or that is 2 here, it means it has got a smaller charge, so it must have a single charge, right? Or it must be the 1. But is it a positive or a negative? You look at nitrogen and oxygen; these are non-metals, so they are your anions. So it's going to be negative. So this one is going to be a negative, right? So the negative times 2 makes it 2 negatives. So therefore, to balance the 2 negatives, so it means calcium must be a 2 plus. Since it is a metal, it must be a positive. So your calcium becomes a 2 plus. So here what you're going to have, you're going to have your arrow, then you're going to have Ca2 plus, plus NO3 minus. Then you balance your equation. I can't do that. My system is slow.
Isn't it 2NO3?
Yeah, come again.
Isn't it 2NO3?
Yes, when you balance, then your nitrate ions are going to be 2. So your final answer is going to be Ca2 plus aqueous plus 2NO3 minus aqueous when you balance it. So the ratio will be 1:2. Then the next one, what about this one here? Al2CO3 3. Aluminium carbonate. What do you get?
Al3 plus aqueous plus 2, no, plus CO3 2 minus balanced.
Okay. All right, let me see if I can open this window, then I do this one. Okay.
So it's 3Al 3 plus.
Yeah. Okay, let me just open this. Then I'll write what you're saying. Okay. Yeah. What are you saying, Joshua? A. So we start with A, L, Al2. All right, that's a 2. That's not a Z, please. Then you've got your CO3. Right, CO3. Then there's a 3 again outside. Right, so when you do your charges, this one is easy. You must just look at the 2. So the 2 basically becomes the charge for this. So this 2 becomes the charge for the CO3, and the 3 becomes the charge for the aluminium. So we're gonna have here aluminium, aluminium. It's a metal. So if it's a metal, we expect it to be positive. So we're gonna have 3 plus. Plus, we've got our carbonate ion is going to be a negative. So we're going to have our CO3. Then here we're going to have 2 minus. Right, then you balance it. Right, so aluminum here, how many do we have? We've got 2. So we're going to take a 2 and put it in front of the aluminum here. So we're going to get a 2 here. All right, then the carbonates, there are 3. Then we're going to have a 3 here to balance that particular equation. Then you put your states. This one is going to be a solid. And this one is going to be aqueous. These two will always be aqueous because they are surrounded by water. So you're going to have your aqueous. Right, and the other one also is aqueous. So that's what you get. Okay, that will be the balanced equation for that one. All right, we've got about 4 minutes left. Let me just go back to that handout. My system is slow. Okay. My system is very slow, guys. Let me see if we will be able to do something in these 3 minutes here. Okay. Let's see. Okay, then we move on to the next one. The next part there, it says electrolytes and the extent of ionization is measured by conductivity. All right, so what do we have? We have, okay, right. When compounds dissolve in water and form ions, the resulting solution becomes an electrical conductor. This property is extremely useful for a large number of industrial processes. Right, so if you take salt, salt is a solid. It's not a conductor of electricity. But if you put it in water, now it becomes a conductor. Why? Because in the ionic lattice or in the crystal lattice where it is an ionic compound, there are no free ions there. But if you put it in a solution, now you're going to have ions. Therefore, electricity will be able to flow, right? So a circuit for measuring conductivity to help us determine how good a conductor a certain solution is, we use a circuit such as the one shown below. So if you take your salt, you dissolve it in water, then after dissolving in water, you connect it to electrodes here. Then these electrodes, they go to a battery, right? Then you close your switch, right? That light bulb there is gonna light if this solution is a conductor of electricity, all right? So if you put your sodium chloride, you dissolve it in water, you close the switch, the bulb is gonna light. Why? Because that aqueous solution of sodium chloride is a conductor. But if you take sugar, you dissolve it in water, right? You close the switch, that bulb is not gonna light. Why? It's because sugar has no solution. Yes, it dissolves in water, but because it's the substances that make up sugar are molecular compounds. There are no ionic compounds, there are no charges. So sugar, you won't make the bulb to light because sugar solution is a molecular compound. Therefore, there are no free ions to make the light glow or to pass electrons in the solution. So this is how you test whether a solution is a conductor or not. Right, guys? I will continue from here, but I'm going to post this today for you to do. Right? I think I'll give the due date on Thursday because you're still busy with the other activities that I gave you. So you guys, please do the quiz and do the consolidation exercise. I don't have much time here. Any questions? Otherwise, we meet again on Wednesday, same time at 2 o'clock. Hello? Any questions? All right. If there are no questions, let's meet on Wednesday, same time. Thank you. Bye.
Bye, sir.
Okay, bye.
Mm-hmm.